All right. Okay. Hello, everyone. My name is Laura Molares, and I am a PhD student on polar geomicrobiology and working with the ICCI this week at the Cryosphere and Chile Pavilion. Today's theme will be all about polar oceans. Our first session of today is the future of tropical glaciers on today's policies. Our speakers today will be Miriam Jackson from the Eurasia and Nordic Director, and Luis Daniel Jambi, Profesor de los Andes, University in Venezuela, and coordinator of the, Adaptation and Altitude Program in Condesan. Thank you very much for your talks today. Take it over, Miriam.
Okay, I'll stand here. Thank you very much, Laura, for that introduction. Can you hear me? I can't hear me. Okay, good. Okay, yes, so actually the main presenter today had a family emergency. He had to go home suddenly, so we've had to adjust the presentations a bit, but I'm sure you'll find them very interesting. So there's over 200,000 glaciers in the world, and there's actually some in tropical countries. There's also some in tropical countries that are disappearing. For example, Venezuela recently lost its last glacier, so these tropical glaciers probably aren't going to hang around. And glaciers globally are melting. This is creating a lot of problems. They're losing 300 gigatons of ice each year. I have no idea how much that is, but it's a lot. It's a huge amount. It's partly contributing to the rise of sea level. There's also other causes for sea level rise, but some of it is from these small mountain glaciers. Cumulatively, they're causing sea level rise. And this is causing lots of effects. For example, it's affecting water supply for downstream communities. Obviously, in tropical regions, they're often very dependent on water from glaciers, from snowpack. So this is causing problems in many parts of the world, including in this part of South America. And they're also leading to several devastating geohazards as well, and I'll get into that a little bit more later. So this is where we have mountain glaciers in the world. This is a figure from the IPCC SROCC report, where I was a lead author. And what you can see, the brown regions is where we have high mountain areas. The blue shows where we have mountain glaciers, and the purple shows permafrost. They're not at the same scale because there's so much permafrost. But you can see that the tropical glaciers, this includes the northern part of South America and Central America, it includes Africa, it includes Indonesia. They are very warm, but they do have some mountain glaciers. And also, if you look at the bottom, I don't know how I can, no, I can't point at things. But if you look at the bottom, you can see that obviously the glaciers in this part of the world are at very high elevations. So glaciers are changing for several reasons, but the main one obviously is temperature rise, so climate change. And the temperature is increasing, precipitation patterns are also increasing, and this isn't, suddenly it gets warmer. Often when you have very cold weather, people are saying, you know, what happened to temperature change? It's not like that. It means that the average, the climate, the average meteorological measurements are going to be warmer. You're going to still have some cold days, but you're going to have, on general, warmer weather and also more extreme heat events. And this temperature rise, has been going on very gradually for the past, since the beginning of the industrial age now, so certainly over the past 100 years. So this is climate change, as I was talking, and here you see basically the values for several years, the temperature and the precipitation, and they vary a little bit. Oh, there we go. Okay, and then this is the temperature, the climate at a later point in the future. You can see that you still have some quite cold years. The average star in the middle is warmer. It could be wetter as well. Many places will be wetter, some will be drier. But it changes gradually. But it does have a big effect on the glaciers. This is actually not tropical glacier, it's the other glacier, but it just shows you the changes in glaciers. And glaciers are a very visible sign of climate change. A recent study called GLAMBI looked at the measurements from different parts of the world. I know there's a lot of information on this, but basically this shows the mass loss of the glaciers. Can you still hear me? The mass loss of the glaciers since 2000 to 2023, I think. And basically anytime you see quite a sizable red wedge, that's bad news for the glaciers in that region. If we look at tropical glaciers, We see in this period since 2000 they've lost over 20%. That's higher than average. That's a lot of ice. You can't keep that up for very long without losing all your glaciers. There we go. So this is what I was saying before, that the tropical Andes are important. They have a lot of diurnal variations and they play a very important role in the dry season. And even under optimistic scenarios, they're going to lose, or realistic scenarios, they're going to lose at least a third, probably all the ice by 2100. So glaciers also cause change in hazards. One of these is, as we haven't time to go through all of them, one of these is glacier lake outburst floods. And this is when you get a glacier retreat and you get a lake forming. There have been several of these in the for tropical glaciers. A huge one in 1941 caused a lot of deaths. And then since the little ice age, there's been at least 160. And these seem to be getting more frequent, actually. This is very interesting. It's another hazard, and I'd like to show this for a couple of reasons. You can also get ice avalanches from glaciers. And this shows the ice coming from a faraway glacier. It comes quite far. It's very noisy. This can also trigger a GLOF as well. So if this went into a lake, it could trigger a glacier lake outburst flood. And you can see it getting nearer and nearer. It's starting to look quite dangerous. To me, this symbolizes climate change. We're standing here. Oops, we didn't get to see the end of it, but anyway, it actually comes up to where the people are filming. If we went to the end, so they're standing there looking at it and realize too late it's very dangerous. They did survive. This to me is very symbolic. This is showing what we're doing with climate change. We're looking at it, we're not doing anything until it's too late. I'll skip that. So glacier mass loss has accelerated in recent decades, so it's not just the glaciers are melting, they're melting faster and faster, also for tropical glaciers. So especially for the small glaciers, they can actually disappear very fast, totally. Sorry, this clicker is just not working at all. Okay, and this shows you the mass loss on different scenarios. So we think, what's the difference? Why is 1.5 important? Is 2 okay? Is 2.6 okay? We don't really change our behavior because of a 1 degree temperature difference. But you can see this has a huge meaning for how much glacier you have left. This is globally. For tropical glaciers, actually be nearly all of them, certainly at RCP 4.5. So the temperature changes that we think are quite insignificant, actually very important for glaciers. And again, this is just another way of showing the different coloured lines show the different temperature changes. There's not much difference between 1.5, 2, 3 and 4. But for the glaciers, it's a huge difference. And again, this is globally, so for tropical glaciers, the difference is even bigger. And the small glaciers, the glaciers disappearing now, they're generally very small, but they are important. There could be small communities that are really reliant on the glacier melt. So as we're short of time, I'm going to skip some of these. If we'll reschedule, I hope you can come back later, but I think you can just see that generally that, the tropical glaciers are very sensitive to climate change. And each difference, each tenth of a degree, and certainly each whole degree has a huge difference on how much glacier mass you have left. I'll go through these quickly. It shows you how much mass loss we have left of the glaciers at different temperature levels. So globally, it's 50% at 1.6 degrees. We're very close to that now. And if you look at tropical glaciers, so for tropical glaciers, again, also 1.6 is when you have 50% left. So we go past that where we haven't got much glaciers left. I went through quite a lot of information here, a lot more quickly than I was going to. There are some policy briefs available on the Andes and glaciers in the Andes in English and in Spanish, sorry, not in Portuguese. But here's the URLs. You can also just look at Antarctic glaciers and do a search, and you'll probably find them. Sorry, did you get that? Oops, sorry, I'm not meant to be there. Can you go back 2 slides? There we go. Thank you. Okay, I don't know if everyone got the URL. Yes? Okay, great. And then also every year we bring out something called the State of the Cryosphere report. This is basically because it's a long time between the IPCC reports. This gives you an update. We will be launching it here tomorrow at 6:30. So I really hope you can come to that. And I really hope we don't have technical problems. Thank you so much. Apologies for the problems, and I'll hand over to Louise now.
Alô? A little bit about the ecological side of glacier retreat in the tropical Andes. So this is mostly about Venezuela, but I'm going to give a more general overview. Ahí sí. Apunto hacia allá. No está funcionando muy bien. Dale, yo te hago así. Aló, aló. Okay, so yeah, here I just put two phrases from two pioneers. One is a lichenologist who said that all living organisms manifest a more or less intimate biological interdependence, and that this relationship is particularly strong at the edge of life, and that's why it's important to study succession. And the other one is from the founder of our group, Maximina Monasterio, who said that the recent uplift of the Andes and the glacial episodes during the Pleistocene produced a new kind of ecology in South America, the ecology of tropical mountains. So this is how important glaciers are for the ecology of the tropics. So the next one. Okay, so this is the scenario. The tropical Andes is the largest and most populated region in the tropics in the world. It's the #1 hotspot for plants also at the global level. And we have more than 95% of the tropical glaciers are in fact concentrated in the tropical Andes. The next one. And we also work as Condesan with the Secretariat of the Andean Mountain Initiative, which is a political platform that unites the 7 countries of the Andes, the ministries of the environment, but also the foreign office ministries, and technical institutions like INAIHEM and Instituto Humboldt, etc. And we have been producing infographic pieces on different topics with a continental view, and this is the latest one that just came out last week on glaciers in the Andes. So you can look at it in the webpage of the Andean Mountain Initiative. And I wanted just to show you a little bit of what we try to show policymakers on the sciences. And this is, for example, the distribution of glacier mass and the glacier mass balance in the different regions of the tropical Andes. And what you can see here is that all across the Andes, these dots are red, which means that the mass balance of the glaciers are in general negative. So in the case of the tropical Andes, we have lost already, in average, in total, 31% of the surface during the last 20 years, whereas in the case of the southern Andes, the situation is less dramatic and they have lost 8%, but it represents a larger surface area in the continent. Yeah. The next. Okay, so in general, as you saw in the previous presentation, this is the average mass balance of many glaciers in the tropics compared to the global average. And what you see is that in general, the retreat rate of mass balance loss is much faster in the tropical Andes than the global average. And what we wanted to look at is what this means for ecosystem development, because this means that we are losing glaciers faster, and the vegetation and the whole ecosystem has to cope with this loss, and new ecosystems have to develop in this situation. Next one. So this is an example from Antisana volcano in Ecuador, and here you see the projections for 2010 and 2100, and what you can see is, as what you already said, that you're going to have 95%, 98% of the glaciers will be lost. But what this means is that there is also new lagoons, for example, that are generated because of the glacier retreat, and a whole change in the ecosystems around the glaciers. And one of the things that are interesting is that you get new plant colonization fronts where the glaciers were previously located. So next. Okay. And very little is known about primary succession in the tropics, and a lot of the research has more concentrated on the water implications of glacier retreat, and you have the famous water peak curve, that you have when the glacier retreats at the beginning, you get a peak in water and then it goes down. But what happens with the whole ecosystem when you have the glacier retreat? The next one. So there has been a lot of recent research on primary succession. These are the case studies that I know of in recent years that have been published in the different tropical Andean countries on glacier retreat and primary succession. And in general, what we see is that there is a slow response of ecosystems to very fast glacier retreat. So I'm going to show you a case study, which is this one at Humboldt Peak in the case of Venezuela. The next one. So this is Mérida, the city of eternal snows, and paradoxically, the city of eternal snows, you cannot see ice anymore from the city. So this was a watercolor from Anton Gehring from the 1870s, and you could see a lot of ice on top of the city. And what we see now is that it has completely disappeared. So the next. So yeah, that makes Venezuela the first Andean country to lose all of its glaciers, and it will continue south. Next one is Colombia, then is Ecuador, etc. The next. So because of this, we proposed this project, which is called the Last Venezuelan Glacier Project. It was financed by the National Geographic. And what we used was a synchronic and diachronic approach to study primary succession in the foreland of the Humboldt Glacier. So we reconstructed glacier retreat, we studied soil formation, we also analyzed the microbiota with metagenomics, and the next. And we analyzed the colonization of vegetation and species interactions to see what's the role of species interactions in the formation of new ecosystems. And the next. So in a sense, the nice thing about primary succession is that it gives you the opportunity to understand how a new ecosystem is assembled from zero. So this is why we were so much interested also in this problem. The next. So this is how we reconstructed glacier areas at a much detailed resolution. So we used interviews with mountaineers. We used old maps from the 1910s. We used old photographs. And using all of that information, we were able to get a very detailed picture of how glacier retreat has proceeded. The next one. So for example, this is a picture that we took and one that was taken by Alfredo Jan in the 1910s. You can see the difference there. The next one. And based on that, we reconstructed at a very detailed resolution glacier loss. And what you can see that this is the cover in 2019. There is only one small glacier left in Humboldt, which now only has 1 hectare. It had 4 hectares here. So it's almost completely disappeared. The next. Well, this is the same, but in numbers. The next one. So what we did is to study also how the ecosystem develops in permanent transects, which we visited in 2019 and we revisited in 2023. And I'm going to show you a few results from this. So the important thing is that as you move away from the glaciers, you move into the past, so you can reconstruct the ecosystem. And we also studied species interactions and the roles of lichens and mosses in the colonization of plants, and the pollination interactions, looking at flowering plants and who visits the flowers. So here you can see inside biological soil crusts that form near the edge of the glacier, the temperatures are much narrower, so you get a dampening of temperature oscillations, which helps vegetation development. The next one. Here you see the development of soil organic matter, and you can see that after 100 years, we still have only 1% of soil organic matter in the soil, so it's a very slow development of soils. The next one. And here you see the changes in vegetation, so this is close to the glacier, and you see that early in succession is completely dominated by lichens, and as you move in time towards more evolved vegetation, later in succession you see that vascular plants start to dominate the landscape, and the lichens decrease in importance, and the mosses also increase in importance. So you see a complete change. And in the next one of the interesting things is that, for example, in terms of plant dispersal, these are the syndromes of dispersal of the seeds. And what you see is that during almost all of the 100 years of succession is completely dominated by anemochoric species, that is, species dispersed by wind. And there is no animal dispersal. So even after 100 years of regeneration, you see no plants dispersed by animals. And that means that this is a really strong filter for the development of the ecosystem in these extreme environments. The next one. This is the pollination network, and you might think, oh, well, it's very complex, but in fact, this is super simple. It's only 6 species of plants, 5 species of animals, and this is after 100 years of vegetation development. So what this implies is that at the speeds that glaciers are retreating and climate is changing, these networks of interactions are super fragile and super simplified compared to what we see in general in the highland tropics. So this means that we are accumulating a climatic debt. And based on this, we just published a report in which what we do, and this is one of the political things that we can do, is to declare these glaciers as critically endangered in the red list of ecosystems of IUCN. And this is one way of showing how dramatic the situation of tropical glaciers is, and we hope that this can be repeated in other parts of the world. This is the first glacier ecosystem that has been put in the red list of ecosystems of the IUCN. And just to finalize, we are also doing efforts to communicate, and these are 2 of the efforts that we have been doing. This is a documentary that we did, you can find it in YouTube, on the formation of new ecosystems after glacier retreat. And this one we just released, and is more on the cultural implications of glacier retreat, because in the Northern Andes, water is not the main issue. The main issue is the cultural identity. And so what we do here is we interviewed rural and urban inhabitants, scientists, mountaineers, tourists, decision makers, artists, to see for them what are the cultural and human implications of glacier loss in the tropical Andes. So yeah, with this I finish, and thank you very much for your attention.
Thank you very much. That was really, really interesting. Would anyone want to ask some questions? Yeah.
Hi, my name is Sophia. I work with Global Choices, which is an NGO focused on like polar advocacy. I'm from Brazil, so it's hard like for people from my country kind of like to see the consequences and direct like impact that melting glaciers are causing. That psychological distance is kind of hard to close, and I was wondering if are there like any like tangible things that can be like said and explained to like people from my country or like in general like countries that don't really like can't associate that.
One thing that is very important for Brazil, as well as many other countries, is sea level rise. And this is something that affects basically any country that has a coastline. It affects very much the low-lying islands, but also any country with a coastline. So I think we're now 10 meters above sea level. This is not going to happen by the end of the century, but with some interesting tipping points, it could happen in a couple of 100 years, say. And it's also just basically going to affect everything, global trade. All shipping infrastructure is at sea level. It's going to affect migration, and people are going to be going to other areas. I know Brazil's had a lot of immigrants in the past decade or so for different reasons. So even if your country doesn't have mountains, and there is actually a glacier meltwater contribution to the Amazon, but it's so small that it doesn't make a big difference. I think sea level rise is the main one that people should be concerned about. And it's happening slowly, but it is happening faster and faster. And it's not just the average sea level, but also the high tide and the storm events that are the things that really cause problems.
Yeah, I would also add, yesterday we had an event that was called Andes Amazon Connections, and we were just discussing this. And one of the interesting things is that what happens in the Amazon has a huge impact in the Andes. For example, 70% of the water of Lima comes from the Amazon, even though people don't realize that. And all of the glaciers of the Andes are fed by rainwater coming from the Amazon. And then this water comes back as sediments, and these sediments fertilize the Amazonian plains. So if you didn't have rivers coming from the Andes, you wouldn't have phosphorus. And if you don't have phosphorus, you don't have trees. So it's really, there is a super strong connection between the Amazon and the Andes that we haven't explored, and that I think we need to understand much better. And for example, fires in the Amazon produce black carbon. This black carbon falls on the glaciers and melts the glaciers. So there is, there are hundreds of connections like this that unless we understand them, we cannot plan. For example, all of the hydroelectric dams that are in the Andes are generating all the power that feeds the Andean countries and Brazil. And most of these dams are located in the Andean Amazon. So really, this is a hot spot for hydroelectric generation, for people. For example, people might not know, but 50% of the people that live in the Amazon basin live in the Andes, in fact, not in the Amazon. So if you don't work with Andean people, you cannot conserve the Amazon. So yeah, these are just examples of how this interconnection is important.
Any other questions? All right, well, I think that's it. Thank you very, very much. This was so interesting, and thank you all for listening. Thank you.
Thank you, Laura.